In this unit, we'll begin by exploring exponential functions. So exponential functions are in this form: f of x equals some whole number to the power of x. A is always a positive number, and a does not equal 1, and x is any real number. So let's graph a couple of exponential functions below to get an idea of what these parent functions will look like. So in this example, we want to, in the same coordinate plane, sketch the graph of each function and state the domain and range of each. So let's start with 2 to the x. So the quickest way to visualize a function is to make a table and input some x values. Our input is x, our output is f of x equals 2 to the x. So the first number I can put in, I'm going to start with positive numbers. 3, 2 to the third is 8. I can plug in 2. 2 squared is 4. I can plug in 1. 2 to the 1 is 2. I can plug in 0. Anything to the 0 power is 1. And now I'm going to plug in some negatives, and this should throw us back to Algebra 1, properties of exponents. If I plug in -1, that's 2 to the -1 power, which is actually 1 over 2, or 1 over 2 to the first. If I plug in -2, that's 2 to the -2 power, which is 1 over 2 squared, which is 1/4. And if I plug in -3, that's 2 to the -3, or 1 over 2 cubed, or 1 over 8. So what you'll notice as you're plugging in negative numbers, note 2 to the negative power of anything is never going to be less than or equal to 0. What this implies to us is now we have a horizontal asymptote at y equals 0, because our graph will never equal 0 or go below it to a negative. So we can see that our domain is going to be -infinity to infinity, because we can plug in any number into our equation, but our range will only be y values greater than 0. That's going to be 0 to infinity. So let's put this all together and graph it. So first, I'm going to sketch my horizontal asymptote here at y equals 0, because 2 to a power will never be 0 or negative. And now I can plot these points. At 2, I'm up at 8. I'm sorry, I lied. At 3, I'm up at 8. At 2, I'm at 4. At 1, I'm at 2. 0 is 1. -1 is 1/2. -2 is 1/4. And then 1/8. And so we'll see this function here will never cross that horizontal asymptote, and this is f of x. So now, how does big f of x equal 2 to the -x compare to this function? Well, we can connect that to transformations. Remember, a negative in front of our x means that we will reflect across the y-axis. So if I think about this, 3/8 will reflect over here to -3/8. 2/4 will reflect to -2/4. 1/2 reflects to -1/2. This point here on the y-axis stays the same, and the rest of the points reflect on the other side. So now we see A negative exponent really just reflects that same graph across the y-axis. So our domain is still the same, negative infinity to infinity. Our range is still the same, 0 to infinity. And our horizontal asymptote doesn't change as well. It's y equals 0. So this is how we can quickly sketch exponential functions.